Determine the exact area of the region that lies inside both the polar curves given by r equals 7 plus 5 cosine theta and r equals 7 plus 5 sine theta, which I've already graphed here on the right. Notice we're looking for this bounded area here. To find this area, though, we're actually going to divide it in half by sketching a segment from the 2 points of intersection, one here in the first quadrant and the other in the third quadrant. Notice the segment divides the area exactly in half. Next, we'll determine the angle theta at the points of intersection, and then we'll find the bounded area between the segment and the red curve, and then we'll double that area to determine the total area. To determine the angle theta at the points of intersection, we'll solve the two equations as a system and solve for theta. Let's substitute 7 plus 5 sine theta for r in the first equation. This gives us 7 plus 5 sine theta equals 7 plus 5 cosine theta. Notice if we subtract 7 on both sides, the 7's simplify out, and we're left with 5 sine theta equals 5 cosine theta. Let's go ahead and divide both sides by 5 cosine theta. On the left, 5 divided by 5 simplifies to 1, and sine theta divided by cosine theta is equal to tangent theta, equals on the right, 5 cosine theta divided by itself simplifies to 1. So let's focus on the interval from 0 to 2 pi. We're looking for the angles where the tangent function value equals 1 in the first and third quadrants. Whenever we have a tangent function value of 1, we should be thinking of a 45-degree reference angle or a 45-45-90 reference triangle. And again, since tangent theta is positive in the first and third quadrants, the angles we're looking for are theta equals pi divided by 4 in the first quadrant, as well as 5 pi divided by 4 in the third quadrant. We can verify this using the unit circle. Recall in the unit circle, tangent theta equals y divided by x. And notice at pi divided by 4, the tangent function value, or y divided by x, equals 1. And the same is true for tangent 5 pi divided by 4. So these two angles will be our limits of integration. And now we'll use the formula area equals 1/2 times the integral from alpha to beta of the square of f of theta, or the square of r d theta. And then again, we're going to double that area to get the total area. So we'll begin with the area equals 1/2 times integral from pi divided by 4 to 5 pi divided by 4 of the square of the red polar curve given by 7 plus 5 cosine theta d theta. This integral would give us this area, but again, we're looking for the total bounded area, which is twice this, and therefore we now multiply this by 2. This will give us the total area of the bounded region. So 2 times 1/2 is 1, so we have the integral from pi divided by 4 to 5 pi divided by 4 of the square of 7 plus 5 cosine theta, which equals 49 plus 70 cosine theta plus 25 cosine squared theta, d theta. For the next step, let's perform a substitution for cosine squared theta. Recall cosine squared theta equals 1/2 plus 1/2 cosine 2 theta, which would give us 25 times 1/2, or 25 halves, plus 25 times 1/2 cosine 2 theta, or plus 25 halves cosine 2 theta, d theta. Let's go ahead and combine like terms. 49 plus 25 halves equals 98 halves plus 25 halves, which is 123 halves. Notice to integrate cosine 2 theta, we need to perform substitution, where we have u equals 2 theta, and therefore du equals 2 d theta, which indicates 1/2 du equals d theta. Let's go ahead and see if we can determine the antiderivative with respect to theta. 123 halves with respect to theta is 123 divided by 2 times theta, plus the integral of 70 cosine theta is 70 sine theta. Then we have plus 25 halves times the integral of cosine 2 theta, which again, performing substitution, we would have 1/2 cosine u du, or the integral of this, which gives us 1/2 sine u, which is really 1/2 sine 2 theta. Let's continue on the next slide. Now we determine big F of 5 pi divided by 4 minus big F of pi divided by 4. Subbing in 5 pi divided by 4 for theta, we have 123 halves times 5 pi divided by 4 plus 70 sine 5 pi divided by 4 plus this is 25 fourths times the sine of 2 times 5 pi divided by 4, which is 10 pi divided by 4, or 5 pi divided by 2, and then minus big F of pi divided by 4, which is 123 divided by 2 times pi divided by 4, plus 70 sine pi divided by 4, plus 25 fourths times the sine of 2 times pi divided by 4, which is pi divided by 2. And now let's simplify. 123 divided by 2 times 5 pi divided by 4 equals 615 divided by 8 pi. Sine of 5 pi divided by 4 equals negative square root 2 divided by 2. So we get minus 70 square root 2 divided by 2 plus 25 fourths times sine of 5 pi divided by 2 equals 1. And then minus 123 divided by 2 times pi divided by 4 is 123 divided by 8 times pi, plus 70 times sine pi divided by 4 is 70 times square root 2 divided by 2, giving us 70 square root 2 divided by 2. And then finally, plus 25 fourths times sine pi divided by 2, which is equal to 1. Let's simplify one more time. Here we have 25 fourths minus 25 fourths, that's 0. And 615 divided by 8 pi minus 123 divided by 8 pi simplifies to 123 divided by 2 pi. And notice 70 divided by 2 is 35, so we have negative 35 square root 2 minus 35 square root 2 again, which gives us minus 70 square root 2. This is the total area of the bounded region of the two polar curves. Again, we set up the integral to find this purple area, but then we multiply it by 2 to determine the total area. And of course, this would be square units. I hope you found this helpful.